Let us look at the next section, students. This section contains 2 paragraphs. Each paragraph has 2 questions. Each question has 4 options, out of which one or more than one option may be correct. Okay. So let's start with the comprehension given for question number 37 and 38. Okay. Metal insoluble salt electrodes are made of a metal covered with a sparingly soluble salt of the metal and dipped into a solution containing anion of the sparingly soluble salt. The silver chloride and the calomel electrode are example of such electrodes. Okay. It is further given that a cell was constructed using these electrodes, which can be represented as this. Okay, so silver chloride electrode is the anode, whereas the calomel electrode is the cathode. Okay. The reaction occurring inside the cell is this, students. The reaction has been specified to us that half Hg2Cl2 reacts with Ag to give us Hg and AgCl. Okay. The E0 value is 0.0455 volt at 298 Kelvin, and the temperature coefficient for this cell is given by dE0 by dt equal to 3.38 into 10 to the power minus 4 volts per Kelvin. Okay, the value of 2.303 RT by F has to be used as 0.06, students. Now let us look at the questions which are given to us related to this paragraph, students. So question number 37, it says, select the correct thermodynamic values for the reaction happening inside the cell. So we have to deal with this reaction, students. The reaction has been given to us and we have to comment on the value of delta H and delta S for this reaction. Okay. So students, we have the value of dE0 by dt. So we know that the value of temperature coefficient dE0 by dt, it is equal to delta S0 by NF. Okay. We can clearly see that the value of N shall be equal to 1 for this reaction, students, as it will involve only one electron. Okay. So we can have delta S0 by F is equal to dE0 by dt, which is equal to 3.38 into 10 to the power minus 4. Okay. So solving for the value of delta S0, students, we have 3.38 into 10 to the power minus 4 into 96500. So this will give us a value equal to 32.6 joule per mole per Kelvin. So we can see that the value of delta S0 is correctly represented in option C. So C is the correct statement, students. Now if we talk about the delta H, students, we can have delta G0 is equal to delta H0 minus T delta S0, students. The value of delta G0 can be written as minus of NF E0, students. And delta H we have to find out. And the value of temperature is 298 kelvins, and the value of delta S0 we had just calculated was equal to 32.6. Okay. So now we can just put the value, students. The value of N is equal to 1. The value of F is 96500, and the value of E0 given to us is 0.0455. So students, solving this equation for the value of delta H0, we have the value of delta H0 as 5324 joule per mole, students. So this can be converted into 5.3 kilojoule per mole. So if we talk about the correct options out of A, B and D, students, we can clearly see that option B is correct. So for question number 37, we have to mark the correct answer as option B and option C. Let us look at the next question now. Question number 38. If E0 of Hg2 plus to Hg is 0.8 volts and E0 of Cl minus AgCl and Ag is 0.2145 volts, then based on this information we have to comment on the value of Ksp of Hg2Cl2. Okay. So students, we have been given the value of E0 for this cell. Okay. So the value of E0 for this cell is given to us as 0.0455. This is equal to E0 of cathode minus E0 of anode when we are dealing with the reduction potentials. So students, the value of E0 of the cathode we have to find out. The value of E0 of the anode has been given to us. Okay. So this can be simplified to 0.0455 is equal to E0 of cathode minus of 0.2145. So this on simplification is going to give us the value of E0 of cathode equal to 0.26 volts. Okay. Students, the value of E0 of cathode is 0.26 volts. So we have E0 of Cl minus Hg2Cl2 Hg equal to 0.26 volts, and we have the value of E0 of Hg22 plus to Hg equal to 0.8 volts. So students, we can find out the value of KSP of this Hg2Cl2 using these two E0 values, students. So we have 0.26 is equal to 0.8 plus 0.06 by 2 into log of KSP. So this equation can be found out by converting this E0 values into corresponding delta G values. Okay, so we're going to have minus 0.54 is equal to 0.03 log of KSP. So the value of log KSP is equal to minus of 18. It means that the value of KSP shall be equal to 10 to the power minus 18. So students, we can clearly see that for question number 38, we have to mark the correct answer as option D. Let us look at the paragraph given for question number 39 and 40. Coniferal alcohol is isolated from pine trees and has the molecular formula C10H12O3. Okay, so we can quickly find out the DU for this compound, students. We can see that the value of degree of unsaturation or DU is equal to 5 in this case. It is not soluble in NaHCO3. It means that it does not contain carboxylic acid group, but it decolorizes bromine water. Okay, so there is a decolorization of bromine water, but there is no carboxylic acid groups present. So it must mean that the compound contains a double bond apart from the benzene ring in the structure. It is further mentioned to us that upon reductive ozonolysis, it produces 4-hydroxy 3-methoxybenzaldehyde, which is the compound P, and another compound Q, which is C2H4O2. So if you talk about this C2H4O2, students, it also has 1 degree of unsaturation. Okay, so it is mentioned that Q decolorizes KMnO4 and is insoluble in NaHCO3. Okay, so it also again implies that there is no carboxylic acid group which is present over here. So Q decolorizes KMnO4, it means that it can get oxidized. So students, if we look at all this information given to us, okay, it is mentioned that upon reductive ozonolysis, the produced product is 4-hydroxy 3-methoxybenzaldehyde. Okay, so these are not affected upon ozonolysis, students, the hydroxy groups and the methoxy groups, and benzaldehyde is obtained. Okay, so it must mean that the double bond must be present over here. Okay, and if we try and figure out the structure of this compound Q, students, so it has to be this compound, students. So this was P, this was Q. Okay, now if we try and figure out the structure of the coniferal alcohol from this P and Q, students, we can see that it has to be this structure. There will be a 3-methoxy and there will be a 4-hydroxy as well. Okay, so if we look at the options which are given to us, students, we can clearly see that the correct answer for question number 39 is option A. Let us look at the last question for this paper, students. Question number 40. Q on reaction with copper 573 Kelvin forms a compound R. Which of the following on reductive ozonolysis does not form the compound R? Okay, so students, if we talk about the compound Q, it was this compound, students, and when it is allowed to react with copper at 573 Kelvin, the alcohol will be converted into aldehyde. There will be dehydrogenation and we're going to obtain glyoxyl. Okay, so this is the compound R. And if you look at the options which are given to us, students, we have to comment on those compounds which do not give glyoxyl upon reductive ozonolysis, students. We can eliminate option A. It is not going to give glyoxyl as the product. If you talk about option B, so in option B, we're going to obtain glyoxyl from the lower half, students. So this is going to give us glyoxyl. If you talk about option C now, so in option C also we're going to obtain glyoxyl from the middle part. If you talk about the last option, this is also not going to give glyoxyl. Okay, so in this question we have to select those compounds which do not give glyoxyl upon reductive ozonolysis, and we have to mark the answer as option A and option D. Okay, so this is it for today, guys. I hope the solutions were clear to you. Thank you.